Hi, this video is about period and frequency in physics. Now, I have here a toy that is suspended by a string. It might be hard to see, but this toy is allowed to freely swing back and forth. Now, in physics, we want to figure out how things work in nature, and so we would look at a situation like this and we would want to start to measure it. We want to find a way to quantify the motion or put a number to it. So what are some ways that we could quantify this motion? Well, one of the things we could do that immediately comes to mind is how far it swings back and forth. So we can measure the distance from one end to the other end, or more consistent with how we measure waves, we can measure how far does this toy go from its rest position here, its equilibrium, to its maximum position away from equilibrium. So we could measure that, and we could try to put a dot over here too to show how far up it goes. So this measurement here from the equilibrium to its furthest displacement is known as amplitude. And so this is similar, a swinging pendulum that we have here is similar to waves because it involves amplitude. So waves and pendulums have a lot in common. So another way that we could quantify this motion is by timing it. We could time how long it takes to complete one full swing. So typically we do this by, seeing how far it goes from, like we'll start the stopwatch here and then we'll stop it once it gets back to my hand. So I've got a stopwatch here, I'm gonna try to do that. So I'm gonna put my hand right here where it comes and I'm going to hit start and stop. So about 1.3 seconds for the time to complete one cycle. And we have a name for that in physics. It's called the period. And you got to think period as in a time period, like in history, a time period is many years, but in pendulums and in waves, a period is the time it takes to complete just one full swing or one full cycle. Now, another related kind of measurement we can make with time is the frequency. The frequency is how many times a pendulum or a wave will oscillate back and forth in 1 second. So we have like a certain amount of time. This time we say it's going to be 1 second. How many times does it, cycle back and forth in 1 second? Now that's not a very helpful measurement for this pendulum because it's pretty slow. It might only have a frequency of 1 cycle per second. It's pretty slow. But for other quicker moving objects and waves, frequency can be very useful. So let's look at a few examples, or let's get a little bit more specific with period and frequency. I'll show you their definitions here, written in a few different ways. So period, let's start here, is the time for one cycle in waves. And period, we use the capital T. Again, it has to do with the time. So the capital T for period, and it's how many seconds happen per cycle. So seconds per cycle would be the period. Frequency, on the other hand, is cycles in 1 second. So you'll notice it's very similar to period, except we've switched the time in the cycle. So now we know the time, but we want to know how many cycles there are. So frequency is how many cycles in 1 second. And we use lowercase f for frequency in physics. So frequency is cycles per second. Now I do have a technical thing that I wanted to point out here to you. A cycle is not technically a unit, but it's really just another way of simply counting. So we're counting how many cycles happen. So 1, 2, 3, 4. So a cycle is really just a number and it's equal to 1. So we could rewrite these units as just putting a number 1 here for cycle. So seconds divided by 1 is just seconds for period. And then frequency, cycles per second, that would just be 1 over seconds. Another unit that we use for frequency, and one that you've probably heard of before, is hertz. And a hertz is just a cycle per second. It's the same thing, just written a little bit more abbreviated here. So frequency is measured in cycles per second or hertz. So what's the relationship then between period and frequency? They seem very similar to each other, just kind of like opposites in some ways. Well, that's exactly what their relationship is. So want you to imagine that we had a pendulum that had a period of half of a second. So that means it takes half a second to complete one cycle. Well, how many cycles would it complete in one full second? So if we let that go, right? Half a second for one cycle, half a second for another cycle, that would be 2 cycles in one full second. So it would have a frequency of 2 hertz, or 2 cycles per second. What about if it was a little bit quicker? So it was able to complete one full cycle in 1/3 of a second. So it goes 1/3 of a second. Well, how many cycles would that be in one full second now? It's going faster, so we have 1/3 of a second, 2/3, 3/3. It would take 3 cycles. So 3 hertz would be the frequency here. All right, then we'll keep the pattern going. What if it's a 1/4 of a second, so even faster? How many cycles would happen in one full second if it can complete one cycle in 1/4 of a second? Well, again, it's going to be 1/4, 2/4, 3/4, 4/4 of a second. That's 4 cycles in 1 second. So it's a frequency of 4 hertz. So I hope you see a pattern here. We have 1/2 and 2, 1/3 and 3, 1/4 and 4. This relationship is inverse or reciprocal. And so to write this mathematically, we would say, okay, the frequency is 1 over the period is 1 over the frequency, which is 4. So period is 1 over frequency, or frequency is 1 over period. They are reciprocals of each other. They're just inverses. So they're very closely related in physics. But that's all I've got for you in this video. Remember, humility is not thinking less of yourself, it's thinking of yourself less.